Hi. So thanks a lot for being here. So just to kind of today, what I'm going to talk to you about is work that's being done within one of our research groups. This is the one that we call the Changing Research Group. But I also wear a second hat, and that is that I'm also director of the environmental geography degree scheme. So I'm not going to talk too much about environmental geography, other than to say that some of the research that you're going to see here is stuff that we talk about, and certainly we spend quite a bit of time talking about in the environmental geography degree. So as Ian mentioned, we have 3 degree schemes: solid, living, and changing. And the Changing Research Group, I've just shown up here the sort of 3 statements of intent for this sort of, or areas of interest for the Changing Research Group. We're a pretty diverse group, so we include people that go out on boats to try and understand the ocean and the past ocean system, so trying to understand past climates through looking at cores and foraminifera. We have people that are interested in the surface of our planet, so this is what I'm going to talk about today because that's where my interests lie, but trying to understand the physical processes that go into creating the world on which we live, right? Physical, chemical, and biological. And then we extend all the way through to thinking about how this affects you guys, people, right? And so here's a really nice picture of some work that a colleague of ours is doing, trying to understand how much slag piles sequester carbon, right? So how mine waste could be a potential carbon sink through time. So we are a very, very diverse group, and there's plenty of opportunity for students to get involved in the research that's being done in this group, and it's something that we can do. So that's sort of an introduction to the diversity of the group. I'm going to talk about today one particular element of the work that I do, okay? And really what it is it's a piece of work that's trying to understand how people bounce back from earthquakes, okay? And this is a concept known as resilience. So how do we build resilience amongst people that have been devastated by something such as this, which is the 2008 Wenchuan earthquake. So just to kind of give you a little bit of an insight into the sort of theory of this. So the idea, I'm probably sure many of you are kind of aware of the idea of kind of hazard and risk. So a hazard is something, it's just a geological phenomena that could potentially affect people. And when it does affect people, we call it risk. Yeah? And the amount of risk that you feel to a particular hazard is dependent on how vulnerable you are. For example, if you're in a hospital that is downslope from a potential landslide site, you're at greater risk than somebody that is able to move or walk away. So these sort of 2 concepts are concepts that many of you may have heard about at A-level or through your life. But really, as scientists, you know, we can kind of come up with models of risk or hazard. But that really isn't the problem. The problem is really shown here. So these guys, this group of people, this family, have been affected by a big earthquake. And what we really want to know is not what risk they have, but how able they are to rebuild their lives after this earthquake, right? So this is known as their resilience. So how can they prepare for this? How can they deal with the shock? And ideally, we would hope that this family will, a few years from now, be in a better situation as a result. They will be more resilient as a result of this earthquake than, obviously right now. And so this is a really interesting way in which, sort of fairly dry academic research that we all sit around and do is being applied to help improve people's lives. And it's something that we're really thinking about. And what I want to do is just give an example of resilience, of the resilience work that I'm doing. And really what I've been doing is working on a particular earthquake, a very large earthquake that happened in 2008 in China. And this is the Wenchuan earthquake, which happened in Sichuan province on the 12th of May. So we're coming up on the 10-year anniversary. Now, this was a magnitude 7.8 earthquake, so a big earthquake, and it killed around 60,000 people. So it's one of the most destructive earthquakes in terms of human lives, certainly this century, but you know, for previous centuries as well. And so, and the problem of rebuilding this area is something that the Chinese government have spent the past 10 years doing. And there's a problem, right? And the problem is that the types of hazards that the government is trying to build resilience to have changed through time. And I want to give an example of this, and the example I want to give is a place called Beichuan, right? So Beichuan actually has a lot of similarities to Wales in that there was a sort of a landslide event that affected a school, so it's a lot of similarities with the Aberfan disaster. But Beichuan sits on the fault line, and it actually sits 250 kilometers from the epicenter of the earthquake, right? So this fault extended 250 kilometers. Now this town has basically suffered every hazard under the sun, right? So this is Beichuan immediately after the earthquake, after the shaking stopped. You can see there's some buildings still standing, but these people have, you know, basically got it. If you've survived, you've got out of the building alive. 12 minutes later, the shaking of the earthquake had destabilized the side slopes there, and there were two landslides. You can see one here, and then this one here that hit the school, that came down. So you've just got out of your building alive, all of a sudden you're running from a landslide, right? And there were further 1,000 fatalities associated with people that were in the paths of these landslides. Then you'll notice that you've got a river here, but there's no water in it, right? Why is there no water? Well, upstream of the river, one of these big landslides had come into the river and blocked it, something known as a landslide dam. So about a month later, the People's Liberation Army flew over it with planes and bombed this thing, right? Because they were so worried about how unstable it was, and so the town got flooded. Okay? Luckily, it had been evacuated long before that, but that happened. So that was sort of about a month later. Then the rains came. Then the monsoon arrived. And so all of this unstable sediment that was sitting around on the side slopes, as soon as the monsoon arrived, then we get these massive and destructive debris flows. Okay? And then finally, through time, the river has started to dump sediment, and it's basically starting to fill in, and buildings are slowly getting subsumed by sedimentation. So this idea of hazards, known as a chain of hazards, is really, really significant. If you're trying to rebuild after an earthquake, you have to then worry about, well, I have to worry about debris flows, floods, landslides, and so on. So this is something that we are kind of interested in understanding in terms of that. And the key, or there's lots of kind of interesting parts to this, but to really understand resilience, we need to go further than understanding hazard, right? We need to understand how communities are built and how communities react after an earthquake. Okay, so this is a photo of the school in a place called Yinshu, which was near the epicenter. Okay. Now, what's interesting about this part of the world is that prior to the earthquake, there was significant corruption around school building. And so the buildings were not made to spec. So every place you go to in Sichuan, the schools were the things that fell over first. Okay. So this is a picture of the school in Yanshu, and this is the result of the shaking. So basically, what happens when you have earthquake shaking? Buildings collapse. You have high casualty rates, and it's indiscriminate, right? So you have a major fracturing of the communities and the social networks. So it's that fracturing of the social networks that is really defining how able you are to build back, right? If the mayor and various leaders are sort of are killed or moved away, then things become difficult. So this is the point at which we start to think, well, how do we rebuild this community? We could relocate, so a number of, because China's fairly authoritarian, they just sort of said you can move to here. So that happened. But also, there's had to be significant changes in that kind of community to become more cooperative, more humane, and so on. But within this, now we need to think about, well, what is coming next? And this is where things get quite interesting. Okay, so I'm going to move now to thinking about one part of the hazard chain, and that is post-earthquake debris flows. So, so rains come, this thing fails, and about when this might initiate. We might be able to think about a way of creating an early warning system. And we've tried to do this. Well, others have tried to do this, and this is the way you would do it. So this is just simply, we've taken a look at how rainy it is, how strong the rain is, how long it's been raining for, and you can say, oh look, these are when all the debris flows happen, so if you have this level of rain, it's been raining for 10 hours, your rainfall intensity is 1 millimeter an hour, get out. Okay? Seems fairly simple, right? But this is a data set that was made after 2008. When we look at data sets between 2008 and 2009, you see that that rainfall threshold is constantly changing, right? So if you said to somebody, it's really been raining for 10 hours at 1 millimeter a year, 1 millimeter an hour rainfall, get out, no debris flow comes. What happens? Next time you say get out, people say, no way, you know, I'm happy here, I'm going to take my chances with the debris flow. So your model has failed, right? So in this context, it becomes quite difficult in this changing hazard is how do we develop a physically based model of doing this, right? Then secondly, if I start to put in or start thinking about when you have what we would call false negatives, right? Where you've got, where you predict that a rainfall event will cause a debris flow, but it doesn't. And it turns out that these blue dots suggest that in many cases, you get big storms that don't. So prediction associated with these kind of big hazards may be a misnomer. Okay? So this is sort of our big problem, right? Is that how is it possible to predict the hazard? And this is an area of significant research. Why are these things so difficult to predict? So I've got another video to show. And so what this is two experiments exactly the same. So you're going to see water come out the top, and this is running across a dry bed. This is running across a wet bed. All that's different in these two experiments is one is wet and one is dry. So, and what we're going to see is we're going to see significant changes or significant differences between the left and the right. The right is more interesting. Comes to the problem of hazard and risk in building resilience. How do we treat something that is interesting but unpredictable? And this is the work that I do. So this is a series of hazard models. The one on the right is where we've been able to kind of model this thing. But we can come up with sort of scenarios for when or for what the extent to which a debris flow will happen given particular conditions. But we can't predict it. Right? And this is where this is again where the challenge lies, because people build structures to stop debris flows. So we try and engineer the world against this, and you know this is very beautiful. So really nice big levee system. But how big is the debris flow that's going to come down the system? How did they reach that conclusion? The best we can guess is that they guessed, right? They said, oh, it's going to be about this big. And the problem is that people say, oh, look, I'm safe and happy here because I've got a levee system. So what they do is they build their house right here. And this engineering solution actually makes more people vulnerable to hazard than potentially not having it at all. And so the conclusion here is that from this work is A, it's really interesting and complicated to try and understand hazard, and then to include that in that risk and resilience. But that we need to start working, scientists need to start working with communities as a way at creating adaptive changes to dealing with hazards, right? Rather than relying on engineering or relying on an early warning system, what we are doing in China and what we're encouraging people to do in China is to start adapting their lifestyle, adapting their planning, changing their planning, town planning, etc., to mitigate against the potential for these hazards, because they are significant and going to be kind of keeping going. So that's just a little idea about how we are working on understanding risk within our communities. In terms of how you get involved in research, so like Ian said, there are a lot of opportunities to get involved in research, particularly in the sort of changing research group. And so these are just some examples of ways in which students have been involved in the work that I personally have done. Okay, so on the top left is a couple of students crossing a place called the Bhutan Bridge, which is in Switzerland, crossing over a place called Eelgraben, and this location here is where you get massive debris flows. So students are able to get out into the field and see the ways in which debris flows are happening, getting mitigated. It's really kind of an interesting place there. So students are able to always get out. We have these research skills that are embedded throughout each of our degree programs that we run. Secondly, there are a bunch of opportunities within the within term time. So I've got examples here of some high school students that came and worked with me on Chinese landslides through the Nuffield research placement. So what we were able to do is sort of develop models of landslide initiation through that, and then also through something known as the Cardiff Undergraduate Research Opportunities Program, so CUROP program, where students in the summer can come and work with researchers for 8 or 10 weeks. And so we basically, there is opportunity to kind of work with students or for students to work with researchers through that. And then finally, this is an undergraduate who was working with me as part of the MSI program that Ian mentioned. And we were interested in deforestation in Borneo. And so here we are in Borneo sieving some soil. It's quite hot there, so that looks like hot work. But in essence, the opportunity to get to embed embed yourself with the research that's being done happens throughout your program. So yeah, there's lots of opportunity here. So anyway, to wrap up, thanks a lot for listening. I'm happy to take any questions, but if you wanted to chat about the degree as well, please come and find me, and I'm around. So thanks.